after randomized controlled trials.
Dear Chairman, dear members of the European College of Sports Science, dear colleagues. This study was conducted at the University of Greenwich in London, United Kingdom, and it is entitled Effects of Microcurrent, which might be a good addition to the previous talk, added to physical exercises on body composition, physical performance, and delayed onset muscle soreness. It's a systematic review and meta-analysis. So microcurrent was developed as a therapy in the 1970s, and it involves an electrical current which goes through the skin of the participant into the human body, and it cannot be felt at all. There is no muscle contraction or any sensations, and it is a non-invasive method and safe method which requires a microcurrent device, and you can see different devices on the slide. The current is so small it mimics the bioelectrical current of our body, hence the name microcurrent, so the participants cannot feel anything during the application. And it has been documented in the scientific literature that there are some potential benefits of using microcurrent. For example, in animal studies, it was documented that it can increase ATP production, protein synthesis, and in human studies, it was documented that it can reduce inflammation and increase wound healing. And interestingly, when microcurrent was added to a program of physical exercises, some articles suggested that it can reduce delayed onset muscle soreness or to improve body composition by increasing lipolysis, the breaking down of body fat. And in our Center of Exercise Activity and Rehabilitation at the University of Greenwich in London, we are particularly interested in exercises and the addition of microcurrent to exercises, and to see whether microcurrent might have benefit on top of the exercises. And in 2023, we published an article, a review article on the topic. We gathered the articles that are published with microcurrent and physical exercises, and the key points of this article are shown on the slide, but we also suggested some mechanisms of how microcurrent might affect so-called to reduce body fat through increase of lipolysis or to increase ATP production. And you can access this article. It's an open article published in the European Journal of Applied Physiology by scanning the QR codes if you're more interested in that topic. Now, the aim of this particular meta-analysis was to assess the effectiveness of microcurrent combined with physical exercises, whether it can attenuate symptoms of delayed onset muscle soreness or it can increase body composition compared to exercise alone. And we conducted a meta-analysis according to PRISMA guidelines. We searched at different scientific databases for records up until February 2024. The inclusion criteria was randomized controlled trials, including adults who underwent an intervention combining microcurrent with physical exercises. And we pulled data such as fat mass in percent, in kilograms, strength parameters, endurance parameters, and scores for delayed onset muscle soreness. And we used the random effect model and the comprehensive meta-analysis software to conduct this meta-analysis. And we ended up with thousands of records, and after reading the abstract and the titles of these records and removing the duplicates, there were about 31 papers were eligible, and those papers that didn't meet the criteria were excluded, and you can see the different reasons, exclusion of that papers, and we had a total of 11 articles for the qualitative synthesis. We're going to the results section. In terms of fat mass in percent, we had a total of 4 studies, but one of the studies, Nuites et al. 2015, used an interesting 4-arm parallel group method, so therefore we ended up with 7 interventional groups for this parameter. And we can see from the effect size that there was a very small effect size. It was insignificant, slightly benefiting microcurrent, but that wasn't significant. Also, 3 of those studies reported fat mass in kilograms. We ran this analysis as well, and we had the same results, again, insignificant results in favor of microcurrent. And we also split the population into trained and untrained people, because some of these studies used trained people, athletes, and other studies used from people from the general population. So overall, we couldn't find any benefits of using microcurrent in order to increase lipolysis and therefore reduce muscle fat mass more than just the exercises. We're going to the next parameter, strength. We had only 3 studies here using microcurrent with physical exercises in order to check whether that can improve strength. And we can see small effect, slightly favoring microcurrent, again insignificant effect. The next parameter is delayed onset muscle soreness. When microcurrent was added to exercises after a hard physical session, microcurrent reduced symptoms of delayed onset muscle soreness here significantly after 24 hours and 48 hours. So that was a significant reduction, and the effect size was moderate. Also, it's important to note that after the 72-hour period, also we can see some reduction, although insignificant. We couldn't find any other benefits for other parameters in terms of microcurrent. So therefore, our conclusion is that when microcurrent is added post-workout, it is an effective and safe method to reduce symptoms of delayed onset muscle soreness in healthy individuals. And with this, I would like to thank you very much for your attention. And of course, if you have any questions or any comments, I'm very happy to take them. Thank you.
Thank you, Stefan, for the presentation, and let's discussion begin.
I have a question because your paper was not published yet when we conduct our search strategy, so we didn't include your data to our analysis. But as I look at your data on the DOMS and microcurrent therapy, I can say that probably it would be in the 4th category of the evidence class in our study, with the quite small effect size. So that's the point where you should be if you conduct your study area.
Yeah. It is not published yet anyway, but yeah, thank you for the comment.
Maybe other questions? Okay, so thank you very much for your presentation. And I think that we have all for today's session. So thank you very much, Konstantin, for a great